All right, hello scholars. I wanted to make sure we did the video of this so that you're all on the same page and we're able to at least attempt the homework tonight. So these are the last two problems of solving for logarithms. So a quick review. Remember, it's not going to do the quick review for me here. Remember, you're supposed to isolate the logarithm, and you might have to use the properties to combine in order to do this. And then you change it to exponential form. Now, I did not change it to exponential form earlier, but I want to remind you what that means, okay? So remember, changing to exponential form is like if I'm saying log base e, okay? And then we rewrite it, knowing what we know the difference between logarithm and exponents are. As long as you do this, you can go e raised to the 7th power is equal to x plus 1. So if you're solving for x, it's really e to the 7th minus 1 is equal to x. So that's easy way of getting the solution. Now, and I was showing you how to use inverse properties. It's a way I learned it. It's probably a little more confusing, so I think it's probably better the way I just showed you. But now let's go ahead and solve the next one. The next one we have to combine our logarithms, okay? And if we're doing addition, are we going to do multiplication? So it'd be log base 2 of x times x minus 7 is equal to 3. All right, so then I get log of 2 is x squared minus 7x is equal to 3. Now we're going to rewrite our logarithm into exponential form. So remember, we're going to go 2 raised to the 3rd power is equal to x squared minus 7x. So we're going back to the very first day when we were switching between logarithms and exponents. I'm being able to rewrite them. So really that's 8 is equal to x squared minus 7x, which, my friends, if you notice, we now have a quadratic. And so then that you should solve. So remember, to solve a quadratic equation, you have to move everything to the same side. So I get 0 is equal to x squared minus 7x minus 8. So then we factor to both sides, and we're going to end up getting x minus 8, and I get x plus 1. We're going to set them equal to 0. So I get x is equal to 8, and I get x is equal to negative 1. Now, this is where you have to be very, very careful. When you're solving for logarithmic equations, you have to check your answers. So when I plug them back into the original equation, like I do right here, notice I get log base 2 of negative 1. Okay, so when you have negative 1, you can't take the logarithm of a negative number. So that makes this an extraneous solution. So you have to check each one. So then I even have to check the 8, and I go 8 minus 7, which is 1, which works. So remember, you have to check your answers. So there are no negative logs, or logs of negative numbers, a better way to say it, logs of negative numbers. Okay, so if I plug back in 1, I get log base 2 of negative 1. It doesn't work. All right, so the only solution for this one is going to be x is equal to 8. All right, doing the same type of scenario, we're going to look at the next one. And this one actually is easier than harder, so guys, go with me on this. It's not that bad. Let's look at the first one here. I need to combine these so I can get all my logarithms on one side. But sometimes life is not as difficult as we make it sound. But first, if I'm adding them together in the same base, that's the same thing as multiplying them. So I get natural log of x times 24x plus 11 equals the natural log of 18. So if you do that, we get natural log of x, oops, excuse me, I did that wrong, of 24x squared plus 11x is equal to the natural log of 18. Now, a lot of people are like, do I have to rewrite this exponentially? And the answer is no. Guys, I want you to look at the fact you have a natural log is equal to a natural log. Basically, don't these two things have to be equal to each other? And the answer is yeah. So set them equal. So I got 24x squared plus 11x is equal to 18. So subtract the 18. So 24x squared plus 11x minus 18 is equal to 0. So now I'm going to factor it. All right. Hint now, you're going to use 8 and 3. So I got 8x and a 3x. And then you're not going to want to use 3 and 6 because 3 and 6, no matter which one you plug in with 3, is going to be a GCF, so we can't use it. So we're going to use 2 and 9. So we can have the 9 here, and we're going to have the 2 here. So let's check. 16x plus, a negative 16x plus a positive 27x is 11x. We set them equal to 0. I get x is equal to a negative 9/8. And then we get x is equal to a positive 2/3. Okay, now here's the deal, friends. We got to make sure I have no negatives when we do this. We have to check. Check. So look at this. Right away, if I plug it back into the original problem, I have a negative. I'm taking the natural log of a negative number. I cannot do that. So therefore, it is considered extraneous. It doesn't work. So don't forget to check your answers. All right, hopefully that will help you get through the level 10 worksheet. But make sure you come in with questions. I don't expect you guys to be perfect on it, but I do want you to at least attempt it based off of these problems.